The geographic coordinate system is used to define locations on a model of the surface of the Earth. The geographic coordinate system uses a network of imaginary lines, the meridians of longitude and the parallels of latitude are used to define locations on the surface of the Earth. Latitude is the distance north and south of the equator, measured as an angle in degrees from the center of the Earth. Latitude begins at the equator and extends to the North Pole at 90 degrees north and to the South Pole, 90 degrees south. The equator is a circle drawn on a globe that is equally distant from the North Pole and the South Pole. It divides the globe in equal halves, called hemispheres. The equator serves as a beginning point to determine latitude and is assigned the value of 0-degree latitude. All parallels of latitude, with the exception of the equator, must be designated either north or south of the equator. One can determine latitude by using a protractor and measuring the angle between the equator, which would be line A here, to the center of the Earth, point B, and then northward to the parallel where the point of interest is located, in this case, point C. So by placing the protractor along the angle ABC, you can determine the latitude. This image shows that if the angle was 20 degrees, then point C would be 20 degrees north of the equator. Early explorers used the angle of the North Star, a star named Polaris, above the horizon to determine their north-south position in the northern hemisphere. So someone standing at the North Pole would look overhead at a 90-degree angle above the horizon and see Polaris. That person's latitude would be an angle 90 degrees north. This diagram shows an observer on Earth measuring the altitude of Polaris and the angle that it creates with the horizon, the angle of 43 degrees. What is the latitude of this observer? If the angle created between Polaris and the horizon and the observer is of 43 degrees, then the latitude of the observer is 43 degrees north. It could not be south because the Polaris star cannot be seen in the southern hemisphere. It can only be seen in the northern hemisphere. The instrument used by the observer to determine the latitude is called a sextant. A sextant is a navigational tool used to measure the angle that a celestial body, such as the North Star, makes with the horizon. The sextant operates on the principle that if two objects can be viewed simultaneously with two mirrors, then the angle reflected by the two mirrors is the angle between the two objects. This angle is an estimate of the latitude of the observer, adjusted for the time and date of the instrument reading. Humans have been navigating the oceans before the geographic coordinate system was designed and sextants were used. For example, the early Polynesian voyagers were able to find their way across the Pacific Ocean, navigating by the sun, stars, and other natural cues. In the northern hemisphere, stars appear to rotate around the North Star. Polynesian navigators could explore the ocean beyond sight of land and always know how to return home by knowing the general location of an island relative to the rising and setting of particular star groups. Master Polynesian navigators memorize the rising and setting positions of hundreds of stars. One way of helping to organize this information is the Hawaiian Star Compass, which divides the sky into 8 families of stars occupying 32 houses. The houses indicate the position of stars rising and setting at the horizon. Knowing which star houses are rising and setting means that you're able to chart a course from your starting point to a specific destination. The Polynesian voyaging canoe, Hokulia, uses the Hawaiian Star Compass to navigate and has made the 2,500-mile voyage from Hawaii to Tahiti many times using only traditional wayfinding methods. Nowadays, the Global Positioning Systems, or GPS, is the common technology used for navigation. A GPS receiver devices send a signal to 3 or more satellites. The distance between the receiver and the satellites is determined by the amount of time it takes the signal to travel to each satellite. The speed of the signal is already known. A minimum of 3 satellites is needed so that the receiver can triangulate its position based on information provided by each satellite. GPS is a device that you have available at your hands right now if you own a smartphone, for example.